suspended the skeleton in the mold and then put the jelly around it. What they got, the ballistics gel, I think it's called. Anyway, it's okay. Welcome. Today's, oh, that's right. I'm going to have you finish up your test. Gentlemen, can you grab these? No, I'm going to send you down to resource. Here you go, guys. And Tyler, you can grab it when you get back. I doubt this will make a duration of the period. So if it does, that's fine too. Okay, so I want you to take this triangle here, call the top A, angle A, call the left side angle B, and call the one on the right angle C.
You're live streaming.
Hi, family.
I want to say hi to you.
Oh.
Did you just record from the little microphone in this thing?
Yeah, which is not a very good microphone. I used to.
Oh, my glasses.
See, now that's recorded forever. You always remember when
We're going to go back in 20 years.
and your glasses broke. And you're like, oh, I remember. All right.
I'm so glad I have Orlando in my life. I'm so glad.
Plug in and everything.
Thank you.
No problem.
I'm his favorite student.
There you go. Thank you so much. No problem. Okay, so we're going to call this A. We're going to call this, did I say B? And that's C? Okay, so that's our triangle. Yep. I'm sure I do. Let's see if we can find one. He said, do you happen to? Oh, Orlando, do you have to have a pencil? Do me a favor, Mr. Dolan. Oh, there we go. It's fine. We got a nice sharpener back there. Thank you, Mr. Dupuy. There you go, my friend. All right, if these are how the angles, all right, hand over, pony up.
I was waiting.
False, you haven't even written what I've written.
It's the alphabet.
It's part of the alphabet. All right, so that's how the angles are labeled. How do we label the sides? This side down here would be called A, and we use a lowercase a. What would we call this side over here? Yep, you got it. And that would obviously make this side B. Remember that we use lowercase for sides, uppercase for the angle they're across from, right? That's going to be our convention for triangles all year. With that in mind, if I was trying to find, let's mix it up and say I was trying to find side C. What would the cosine law be? So the cosine law to find a side. Anyone remember from yesterday? They feel like taking a break? I feel like taking a break. You like taking a stab at it? Yeah, give it a shot. Yep.
So it would be like C squared.
Yep.
And then equals A squared. Equals B squared.
Very good.
And then, I don't know if you do like is it the two that goes there?
Yep.
And then you do like your A and B.
Yeah.
And then your cosine C.
Very good. And what goes here? The only thing we're missing. That was great. Good job. Is this one? Minus. Very good. Very good. So we add, then we subtract, and then all of these are what? 2a, b, and the cosine of c, all of those are being multiplied. So we add, we subtract, and then everything else is multiplication. The side we are looking for obviously goes in front, and the only other time we see that letter, at the end. On the left, it's the side. On the right side, it's the angle it's across from. Does that ring a bell? So we would use this when the information we have is B, A, and this angle. Does that make sense? We only use the cosine law to find a side if it looks like this. And the reason is if we try to use sine law, which is obviously easier than this, right? This is kind of sneakier than sine law. But if we tried to use sine law for this, we don't get fractions that we can use. So we only use cosine law if sine law is impossible. And that's the equation. Yeah, in this case, we don't know anything. I just threw it up there. But what I want to show today is sine law can also be useful to find an angle. You all done? Oh, calculator. I was going to say app, and then enter. So that button right there. Yep. So again, and then just enter. One more.
Thank you so
There you go.
much.
And when you want out, second function quit.
Thank you so much.
No problem. Okay, so let me think. I want to do a little bit of algebra, and you will never have to recreate this. But let's imagine that we have A, B, and C again. What would we call this side? That would be B. Very good. What would we call this side over here? Crazy. What do you think? What do we call this guy right here? Very good. And obviously that makes this fella down here A. If we took the same equation from above, C squared equals A squared plus B squared minus 2AB times the cosine of C. What is the only angle in this equation? Yeah, very good. The only angle is cosine of C. So the only angle I could use this equation to solve for is that one, right? That makes sense? Okay, what would I have to know? I have to know everything else in here. So to find an angle in a triangle using cosine law, what am I going to have to know? I'm going to have to know side A. I'm going to have to know side B. But I'm also going to have to know side C, right? Because the only thing the only thing that can be unknown to me is what I'm looking for. So if I know all the sides, I can find one of the angles, any one of the angles. Now, we'd have to rearrange this. You will never have to recreate what I'm going to show you, okay? At the end, I'm going to draw a box around one, and that's the one we're going to use every time. Does that make sense? I just want to show you where it comes from. So if I wanted to set this up to solve for the angle, I want to get the angle by itself. I want to move everything that isn't cosine C to the other side of this equation. So what all do I have to move? The 2, the A, the B, and the B squared, and the A squared, right? Does that make sense? All that crap has to go. It's all where I don't want it. And a good rule of thumb is do your addition and subtraction first. So I have an A squared that I want to get rid of, so I'm going to subtract A squared. Does that make sense? I have a B squared that I want to get rid of, so I'm going to subtract. Anyone? I'm trying to get rid of B squared, so I'm going to subtract B squared. Does that make sense? But what I do to one side of an equation, I have to do to the other. So over here, I'm going to subtract A squared, and I'm going to subtract B squared. When I do that, the next line of this equation would be C squared minus A squared minus B squared. I've just subtracted both of those. And on this side, these cancel each other out, right? If I have positive A squared and negative A squared, that's gone. Same with B squared. So what's left over here? Negative. Negative 2. There you go. Times A. Good. You got this. Times B. Times. You got it. There we go. Now, I still want to get cosine of C by itself. But the nice thing is, what are all of these doing now? We said after the A and the B, everything over here is being multiplied. So to get rid of it, I have to do the opposite. What is the opposite of multiplying? Dividing. So I'm just going to divide this whole side by negative 2 times A times B. And what I do to one side, I have to do to the other. And what I end up with is C squared minus A squared minus b squared over negative 2ab equals, what's going to be on the right side now? That's all going to cancel with all that. And what remains? The negative 2 canceled with the negative 2. The a canceled with the a. The b canceled with the b. What's left over here? Cosine of c, which is what I'm looking for. And this is the equation we're going to use. Now, I'm going to put it so that the cosine c is on the left side. And I'm going to clean up. There's a lot of negative signs there. Everyone see that? So what I'm going to do is I'm going to multiply the top by -1 and the bottom by -1. And if you multiply the top and the bottom of a fraction by the same thing, you don't change anything, right? I'm just going to clean up. Instead of 3 negative signs, I can make it so we only have 1 negative sign. Same fraction. If you didn't do it, if you left it like this, it would still work. It's just, this is how you'll see it in a textbook. Oh, go away, Chris. And we end up with this equation. By the way, will you ever be asked to redo what I just did there? No. No, I will never. Okay, honestly. I don't want to tell him anything. I want him to stop texting me so I can keep working. Well, now I've lost my page. What I'm going to text him is, some of us are trying to teach here, Mr. Cleaves. Anyway, what we end up with is the a squared being positive, the b squared being positive, and the c being the only thing in this that's negative, and 2ab down here. And this is the cosine law. By the way, the letters don't matter, right? Just like yesterday, I'm going to make you do this with X, Q's, and R's, and D's, L's, and M's, and N, D's, and W's. The letters don't matter. Yes? It could be. And cosine can be negative. Sometimes cos is positive, sometimes cos is negative. That's a great question. And cosine is negative for any angle bigger than 90, and it's positive for any angle less than 90. So yeah, you're right. You may get a negative cosine, and that's okay. That's a great question. The thing I want to note is that the angle we're looking for obviously goes on the left side because it's what we're looking for. And the only other place we see that letter is the one up here that we are subtracting. Does everyone see that? That's going to be our rule. So when we write a cosine law, the angle we're looking for goes here. And then it's the other side squared plus the other side squared minus the matching side, and that should also be squared. I almost neglected something big there. Make sure that is squared. Oh, thank you. I should have done that. Now, these are not particularly tricky questions. One of the things that's actually kind of tricky about them, bless you, is just getting it into your calculator. So we're going to do a little bit of practice of that. Okay? So I've given you one below that we're just going to practice punching in. And the advice I'm going to give you some advice. There you go. Bless you. So this could be an example of a triangle. And I checked it. This one actually works. Last time I taught this lesson, I stupidly just picked random numbers and I made an impossible triangle. That was dumb. So this one works. This is a legit triangle that actually will not give you an error on your calculator. And I want to practice just punching this in. And the thing I want to note is this. These bottom three things are all doing what operation to one another? Multiplication. But on the whole, this line means we are doing what with all of this? Dividing. So the way you have to punch this into your calculator is your calculator has to understand that you're taking the whole top and dividing it by the whole bottom. And what is the way to trick your calculator into doing that? Brackets. So let me show you. The first thing I do to help myself on the inside is I'm going to put brackets around them here. And then even more, it might not be a bad idea the first few times you do it, write it out like this. 7.9 squared plus 10.1 squared minus 6.6 squared. And I put a bracket around that whole thing because that's the top of this fraction. Does that make sense? And then I'm going to divide. And what am I immediately going to open? A bracket. And then I'm going to do the bottom. 2 times 7.9 times 10.1. And then I'm going to close the bracket and press enter. So everyone take a moment and do that, and let's make sure we all get the same answer. And it should be a decimal. It should be decimal something. Press the over button. Like on the arrows, press the right arrow. Yeah, if you get trapped in the exponents, different calculators handle that differently. The over button gets you out of the exponents. Interestingly, even though these are all the same calculator, they have 3 different versions on of the software between them. So everyone's a little different, just to make life fun. Oh, that's because it's here. Okay, so when I punch this in, I open my bracket, 7.9 squared plus 10.1 squared minus 6.6 squared divided by, then I open a bracket again, 2 times 7.9, times 10.1. Does everyone have something similar to that? Okay, when I press enter, I got, where did I? Can't say, because that is not right. Oh, I did. Okay, so that was dumb. I should try that again. Probably you'll do much better than I am. 7.9 squared plus 10.1 squared minus 6.6 squared divided by 2 times 7.9 times 10.1. I like that answer a lot better. Did anyone else get that? Okay, I want you to take a minute and make sure you do in fact get that. Because if you don't get that, then we're not punching this in right. Does that make sense? So take a minute. Now, let me ask you, is that the angle A? Is my angle 0.75 degrees? How do I actually find it in degrees? Well, when we did sine law to find an angle, we had to use second function sine, right? We had to look up the sine. In this case, what am I looking up? I'm looking up the cosine. So how am I going to punch this into my calculator? I'm going to say that the angle A will just be the cos inverse of 0.7574. Oh, and on your calculator, that will be second function cos, and then 0.7574, and then enter. And you have to make sure that your calculator is in what mode? Very important, it's set to degrees, right? If it's set to radians, you'll get a crazy nonsense number. So we can say the second function, the cosine of that answer, and I got 40.8 degrees. Did you get the same? Okay, so show me, let me see what you're doing. Yeah, if you say 41 degrees, that's great. Okay, so you have to put brackets around the whole second thing. Does that make sense? So try it again. Your first half is great. But then in the second half, this all needs to be brackets. Because what you're telling your calculator is I want to divide the whole top, brackets around it, by the whole bottom, brackets around it. Yes, ma'am. Yes. Oh, because how you do it is second function cos. There. Yep, that's what's wrong. Yeah, it's not an exponent. It looks like an exponent. It's actually a terrible notation. The British don't call it cos -1. They call it arc cos, and they write a cos. And that means better because you don't think it's an exponent. exactly right. Yeah, I'd love to. Okay, does anyone have any questions about punching that in? Now we're going to do an actual question. We're going to see it in action. So just a reminder, the cosine of whatever side it is you're looking for is equal to side squared plus side squared minus the one you're looking for's opposite squared over 2 side times side. Right? The letters don't matter. The important thing is look at the ones that match. The angle we're looking for gets paired up with the one that's subtracted. I kind of like showing the formulas this way sometimes because then you don't get hung up on A, B's, and C's. In fact, let's not call this angle alpha. Let's call this guy, oh, I don't know, HRB. Oh, yeah, there we go. HRB. Sorry? H&R Block, sure. File your taxes. Now you know how. Don't pay H&R Block to do it for you. So if your triangle HRB, note, I have 3 sides. This is the classic time we use sine law. This can come up in construction quite a bit. Often in construction, it is very easy to go out and measure, if you have a triangular structure, 3 of the sides. Right? So say you had roof trusses and you had to know what angle to build something against them. So you have to know what angle that roof's going to be at. They don't sell you roof trusses by the angles. They actually sell you roof trusses based on lengths. You would say make the bottom this long, make the sides that long. So you could have a situation like this where you know all 3 sides. If I want to find the angle, I can't use sine law because I won't get one good fraction out of this. And we can only use sine law if we get one good fraction. So this is the most common case where we use cosine law, where you know all 3 sides and you want to find an angle. Does that make sense? This actually comes up a lot, especially in building, in surveying, in construction. If any of you becomes an air traffic controller, air traffic controllers, have you ever seen a show or read a book or read an article about their job? It is the most stressful thing in the world. Because you have hundreds of planes coming towards an airport, and your job is to make sure they don't hit each other or run out of fuel while they're waiting to land. And as it turns out, that's incredibly stressful and difficult. And the average air traffic controller lasts something like 5 years in the job before having a nervous breakdown and having to quit because it's just so stressful. But one of the things they train them to do is, God forbid the power goes out, they need to be able to pull out a map and a bunch of pieces of paper and a calculator and do stuff like this, in an instant, so they can know where everything is and where to tell people to go and what to do. It's some seriously crazy stuff. Anyway, if these are the letters of the angles, what would I call the sides? What would this side be? 16, what's it? It is H, c'est vrai, merci beaucoup. Et qu'est-ce que c'est le 9, mes amis? What's 9? What is it? B? Ah, c'est vrai, merci. Et qu'est-ce que c'est 19? Is that even a thing? Yeah. What is it? It is R, indeed. Are you judging my French? You can't say the letters badly. I think you could. I have faith in you. All right. So I want you to take a minute and set this equation up. Given that we are trying to find what angle, we are trying to find H. So set this fellow up. So I'll start you off. You want to find the cosine of H. And my advice, don't waste time in paper writing one version of it with the... Where is the side across from H going to go? only one place, only right there. You should only see that 16 once in your equation. Both of the other sides you're going to see twice. So take a minute and set that up. Dear Mom, how do I set this triangle up? Dear Michaela, get to work.
I know. Texting my mom is the
Oh. Okay, well, I support food. You'll have a tough time eating with your jaw wire. I was going to threaten to break your jaw, but really that seems hyperbolic. And I am recording this, so instead I'm going to not threaten to break your jaw. That's right.
What one would be first?
It makes no difference. Like in terms of the 9 or the 19?
Yeah.
Yeah, it doesn't matter. The only thing that matters is that the 16 only goes at the end. Yep. Let me take a look. Yeah. That's perfect. All right, now just remember when you go to put it in your calculator, we do the brackets around the whole top, divided by, open a bracket, the bottom, close a bracket. You need brackets. And in my mind, it helps to actually write them on your page so I don't forget them. Because 99% of the time people get one of these wrong. Everything they wrote down on paper is good, and then they screw it up when they try to put it in the calculator. So that's what we want to watch out for. Okay, let's do this. Let's do this question. Come on. Come on, get on, dude. Let's go. Let's label it. Too early. 10:30, dude. You've been here since 8.
No, I've been here since like an hour.
All right, fair enough. Get to work. Did you sleep in?
Okay.
I slept in today too.
It hit snooze on all 4 of my alarms.
You 4 like 4 on the phone?
Yeah.
Just right from that's funny. I do that sometimes. I have started putting my phone like high up on a shelf across the room from me, so I have to get up and groggily like go. Rawr.
Yes, I tried that. That didn't work because I didn't hear it because it was too far away. Even though it was on like full power volume, I still slept through it. So I ended up just putting it by my pillow. That works, but then I just turned it off. So I'm gonna try it under my pillow. That probably won't work either. I'll probably just turn it off.
You should like put one of those like suction cup holders like on the wall right behind you, or the window if you have a window against your bed. That's or the wall.
I know, is this right?
Well, probably, but let's right there. Let's talk about setup first. How do the numbers go into this? So if we look at our version up here, what 2 sides are going to go in these boxes on this guy? Doesn't matter what order they're in. Like somebody want to give me what I should put in this top bracket? Hunter, what do you got?
9 squared.
Yep.
Plus 19 squared.
Yep.
Plus 16 squared.
Very good, thank you. And again, does it matter if you put the 19 first? Just as right, just as correct. Good. Somebody want to give me what they put on the bottom bracket? Very good. Okay. Now the tricky part is making sure we put this into our calculator without ruining all our hard work. So what do I do first? Open a bracket, and up there I do 9 squared plus 19 squared minus 16 squared. Then what do I do? Close that bracket and divide, and then what do I do? Open a bracket. And what goes down here? Good. I close the bracket. My advice, don't use any other brackets. You really shouldn't need to. To make it less cluttered, to make it less likely that you miss one, for this particular type of question, I would just do a set of brackets around the top, divided, set of brackets around the bottom. You're just less likely to screw it up then. And when I do that, I should get a decimal, right? It should be somewhere between -1 and +1. And I get 0.5439 if we round. Am I then done this question? Is my angle 0.5439 degrees? Yeah. By the way, is my angle 54.39 degrees? Because people love to do that. They're like, oh, that doesn't make sense. Oh, wait, I got it. Right? That's human nature. Just be like, that looks like an angle, 54. But no, I have to inverse it, which on my calculator I accomplish by pressing what buttons? Very good. And we call that the cosine inverse. But really, it's just looking this value up. If we had a chart in front of us, we'd look down to the table till we found 0.54939 under cos, and we go over and look at what angle that is. On your calculator, you're going to press second function, cosine, and then 0.5439. And when we do that, we get that h is what? 57? Fantastic. Good. And we could go put that in there, 57 degrees. Yeah, you bet. Questions about that? Does that make sense? It's not so bad, right? If you wanted to keep going now, you could solve the next angle using sine law, which is easier and quicker. And then the third angle, you'd know just because all three have to add up to 180. So solving a whole triangle isn't much more work than this. You would do the first one with cosine law, second one with sine law, third one just 180. If you like cosine law much better, you could do 2 angles with cosine. Hell, you could do 3 angles with cosine law, right? Just keep shifting what angle you're looking at. Most people prefer to switch to sine law. They find it to be a bit quicker. Though really, it's not a long calculation, is it? Okay, we'll try one more together. Let's call this DGB. Comes out. Did you use different letters? Did you use A, B, and C?
Yeah.
Boring. It works, but that's okay. We should get the same answer. That's the important part. Oh, there you go. So we agreed a little bit. It's actually unlikely that 2 people pick it. Like if you picked A, B, C, but in random, I guess you always put them in kind of an order. Well done.
Christmas.
Merci. That's what I've always wanted. Do you have a copy of today's notes, sir? Oh, I put on there. Did I put on there for you? Perfect. There you go. You're welcome. Okay, so what angle am I actually looking for here? G. So take a minute and work on that. I will come around and... Yeah, keep it. I did look at the top. You had a picking up, okay? Shut up. How do you doing? You also need to shut up. And also needs to shut up. And also oh, I like this. Yeah. Yeah, no problem. I want you, Tyler, not to worry about anything that's above this. That's a big waste of time for what we're doing. That's the equation we're using. So this is if we're trying to find an angle. That's the equation. This is just calculator practice. I want you to make sure you can plug this into your calculator and get this. And then we'll go through that example in just a minute. Everything above it was just kind of explaining where it comes from. Okay, so you lost it then. So this we went through together, and that makes sense to you? All right, cool. So now you're doing is to find a sine. God bless you. Or a new on the side.
Having said that, it should give you that. Except that as we do. Ready? It helps. Take that 80 that you found and put it on the triangle. Where will it go? Fantastic. Now, the reason you're in trouble is because with this, if you're looking for B, this would have to be B, but we don't know B. Does that make sense? So that means we can't do this, which is okay. I wouldn't ask you that because it's impossible. Does that make sense? So you're trying to find something that you can't find with this. But your thinking is good, but it helps to physically draw what you find. Once you get it, put it on the triangle. Right? Because then in your mind, you're like, oh, I know. Does that make sense? Cool. Yeah, let's jump on to this one. Okay? Cool. Oh, what did I ask for? Oh, you need the other angles. Aha. What you can do, sorry, as I've drawn the question wrong, do the exact same thing as this one, with the fraction and everything, this time for B. Just like this, the fraction, top and bottom, but for B. Try it over there. Okay? So for now, I just want you to punch it.
I did, and I got a negative.
Good. Let me explain. The trick is only use brackets once. Otherwise, for this down here, it all means multiplication. So let's go open a bracket and do just the top. So 7.9 squared plus 10.9 squared is 6.6.
Just related to check my work. Are you done?
Yeah, I'll be right there. Okay, then I want you to close the bracket. Okay, pause. So you've got the whole top in
You
here.
get the answer.
No. Just pause. We've got the whole top in there. Now we want to divide. Let's divide. And now we have to put the whole bottom around the open bracket. And then do this not as brackets with the parentheses. This means multiply. So do 2 times 7.9 times 7.1. And then close the bracket. And that makes it easy to manage. So the whole top of the bracket, the whole top. Beautiful. There you go. Yeah, can I see? Yeah, that was good. Well done. Let's take it up in a moment. Actually, where is he? I'm so miserable. I'm like, I really want to really flip for that time. It's maybe grumpy ever since. There it is. Aha.
Yeah.
Okay. You do me a favor and write that in front of me. Just right there. Thank you.
Oh no, my writing is horrendous.
Okay. Okay. So with triangle
what is this?
DPG, the one you've just done.
How do I fix it? It's on highlighter. How do I fix that?
Oh, I'm sorry. Click these 3 dots up here. Yeah, and then
Okay.
pick whatever pen you want.
Ooh.
Sky's the limit. And then you can just erase that with the,
Whoa.
there you go. You got it. It always weirds me out watching somebody else write on that because I'm so used to being the one who writes. It's kind of creepy as the words just appear all on their own.
Oh no.
See? Fantastic. Yeah, love it. Yeah. Do me a favor, just so we know, put a little multiplication sign between those.
Okay.
Yeah. Perfect.
I'll be writing.
No.
Pretty good, actually.
It's-
When you first start writing on that,
You remember your nickname?
Disgusting.
It's
disgusting. Okay, so let's take a look. Well, Micmac's doing this. That looks great.
Please don't call me that.
I will never again. I'm sorry. I regretted it immediately. Okay. Now, about half of you made the mistake I wanted you to make.
Can I continue writing?
Yeah, keep going.
Okay.
And about half of you didn't. So I'm going to pause, Michaela, at this step, and we'll write this line.
Okay.
So that first one looks great. You'll notice that we're looking for G. It's a thermometer. Screen is 21.9 degrees Celsius. We're looking for angle G. Side G only gets written once up there, all the others twice. Now look, when you plug this into your calculator, what number came out? Yeah, what do we almost have perfect about this? This number is negative. So I need you to put a negative sign in front there.
Oh.
And I want you to try the cosine inverse again.
Hold on. I don't like that.
It's subtracting. But it leads to this being a negative number. So it's 3.1 squared plus 4.3 squared minus 5.9 squared. And when you do it, this is negative. So I want you on the calculator to do this next step again, Michaela. So if you put that in as positive 0.2516, you should have got 70-some degrees. What did we get?
Where's the calculator on here?
74.6. That's, yeah, you have to remember. Oh,
that's not the calculator.
no, just use yours.
Oh, okay.
You don't have to show.
Okay.
That's right. Beautiful. And when you actually do this, you should get an angle bigger than 90 degrees. Anytime you get a negative cosine, you get an angle bigger than 90. So this is probably going to be 100 and some degrees. Maybe between 1 and 105. All right? Okay. Nice. Perfect. That's good. So just be aware. Look here.
It says error on mine.
Let me see.
Did I do it right?
That's interesting. Oh, you have to use the negative button, which I hate. I wish they didn't have a negative button. It should be the same button, but it's not. So listen, this actually adds a bit of a wrinkle. With sine law, you could never get a negative number, so you never had to worry about this. With cosine law, sometimes the numbers are negative. Don't ignore the negative. The negative is part of the answer. Oh, G, I think on this one, yeah?
Oh, mine's H. Wait,
oh,
what?
is yours H? Yeah. Oh, yeah, G. Nice.
5.
That's great. Good job. Thank you for being my guinea pig. Oh, and a happy face.
It's a cowboy hat.
Oh, I like his cowboy hat. Do you know the expression, I have my uncle, can I tell you guys a story before I make you do math? Okay.
Of course.
So my uncle is a doctor, and he lives in Sudbury. So his name is Sanjif Mather, and he's not my uncle, like he's my uncle by marriage. So he's Indian, as in from India. His family is first generation Indian Americans, and he is just a character. He's got the biggest sense of humor. So he grew up in Ottawa, so he speaks with just a sort of typical Canadian accent. He doesn't have sort of an Indian accent, but when he used to drive across the border with me, he'd always put a really fake one on at the border. So he'd be like, "Oh, hello. Yes, I'm just taking my nephew to the game." And then the guy would be like, "Oh, okay." So, and then as we were leaving, he'd always be like, "Thanks a lot. See ya." And it was funny every time. So anyway, my Uncle Sanjif went to he's a diehard Dallas Cowboys fan. So he flies to Dallas twice a year to go see Cowboys games because he's a doctor in Sudbury. So they make a lot of money. So he works really hard. I mean, my God, whenever you go to visit him, he's on call and he's getting phoned out to go to surgery, emergency surgery at 3 a.m. He's an anesthetist, so he's the guy who puts you under if you have to go in for surgery. So their schedule is a mix, right? All the scheduled surgeries, they just go do, but then they also, 1 week out of every 4 are on call. And that's if somebody comes in the middle of the night and has had an accident, you go in and you do it. So he's a really funny guy.
And so he and another doctor flew down for the first game at the new Dallas Cowboys Stadium, which is about 5 or 6 years old now. But at the time, it was brand new. The first home game that was played there, they flew down, and they went on like StubHub, and they got box seats. Somebody had put the tickets for a box seat up on StubHub. So they go to this thing, and they dropped a fortune on these tickets. I mean, he spent a lot of money. So he goes, and he is like a very serious guy. He's not much of a partier. He said, like, Joe, I paid a fortune for these tickets, way too much money. So we were having a good time. So they were drinking maybe a bit more than they should be drinking. And so they get chatting with this woman from Texas who's next to them in the box. And she says, where are you from? And they said, oh, we're from Sudbury, Ontario. She said, where is that? And they said, oh, you know, it's in Northern Ontario. It's about 5 hours away from Toronto, this and that. And then she said, oh, yeah, well, what brings you here? And my Uncle Sam was about to say, oh, you know, we're just Cowboys fans. And his buddy, who's also a doctor and has had far too much to drink at this point, says, oh, we're friends with Jerry Jones. And that's the owner of the Dallas Cowboys. That is not true. My uncle has never met Jerry Jones. This guy has never met Jerry Jones. But, and the lady said, oh, really? And he said, yeah, we met him in Sudbury once. And my Uncle Sam, who never wanted to miss a challenge, said, yeah, it's the craziest thing. We were on this fishing trip once. So he said, there's this tiny island we go to that you have to get a plane to go to. And there's some fishing huts there. So we were there. We went out for the day fishing, and we came back. And as we were just getting ready to, you know, make our bonfire for the night and chill out, somebody starts yelling, you know, does anyone know CPR? And we run over. This guy has collapsed. And so I started resuscitating him. And we're both doctors. You know, he's a surgeon, and I'm an anesthetist. That is true, at least. None of the rest of the story is true. And he said, so this guy had a serious heart problem. And so believe it or not, we actually got him up on a picnic table and we cut him open right there in northern Sudbury. And we performed open heart surgery on him right there. And later we got a medevac and we got him to the hospital. Turns out it was Jerry Jones, owner of the Cowboys. So he said, well, you've got to come down for opening day when we open the new stadium. So here we are. So they're thinking they're pretty proud of this story. And she goes, oh, well, he'll be so glad to see you. I'll make sure we go down and say hi after the game. So they've made this whole story up. And now when the game is over, the lady goes, come on, let's go down to the field. And they're like, dude. And Sanj goes, we got to get out of here. And the guy goes, are you kidding? We'll never get this chance again. So they go down to the field, and now they're on the field. And again, having had a bit too much to drink, Sanj is grabbing footballs and trying to kick them through the uprights and this or that. And then he sees the lady talking to Jerry Jones and pointing at them, and Jerry Jones not looking impressed. And they decided to beat a hasty retreat and get out before security got them out. But anyway, that's my uncle's Dallas Cowboys story, which I think is pretty impressive. They convinced some poor lady from Texas that they'd performed open heart surgery on Jerry Jones with nothing but like a fillet knife and fishing wire, which I don't think you could do. Okay, I've left you with a few questions to go through. It's not too many, actually. What I want you to do, though, for these sine law questions, I want you to find all three angles. You can use sine law twice, or cosine law twice if you want. You can use cosine law 3 times. You can mix and match. Do the first one with cosine law, then switch to sine law. Lots of different ways to approach these. None right or wrong. So I got these 2 questions done, but I want to know all 3 of the angles, not just one of them. Okay? What order you do them in? Totally up to you. I have